Okay, back. Been a little while between updates. I'm going to keep this one pretty short. It's not because I've not been working on the EMS Spectre clone. It is because I've been sick. I've had a terrible cough and a cold and all that horrible stuff, but I wanted to... we can see up in the top right here that we've got the what is streaming in from my FPGA. I'm just using a cheap ass HDMI capture card. Boop. So that's what it looks like when it starts up. So the method for communicating to it at the moment, termite, is talking to it via serial. So let's see if we're on. Yep, great. So at the moment, the convention that I'm using, and there's going to be a whole kind of language of addressing stuff within it. I mean, the eventual plan is to have an interface and knobs and buttons and MIDI and all that jazz. But as part of debugging, and we'll probably keep it in the end just because it means that you can set up stuff directly from your computer pretty quickly, is to keep the serial interface. So at the moment what's happening is input 10, routing to output 50, and 1 means place a pin in there. So go 45 and 11. Hey, and so this is not a fun way of interacting with the EMS Spectre. No, not at all. This is how a computer thinks, and that might be fine. Remy has created a prototype interface here. So it's a bit laggy because it is very much in the early stages. So this lets us make connections in a way that we can actually read. At the moment, it's set up to only place 1 pin in the matrix per output. So that's not as fun as it could be, obviously. Let's see. So I'm going to take some of our counters here. So I've been using this software to go through and test that all the elements... tested all the elements that we've got placed inside the FPGA design. The FPGA is sitting just below me here. That they're all there, that they all work. So at the moment, what I have done, let's take that off, is I've routed a couple of the X counters to the Luma outputs. So why is there this color shift? Great question. That is for me to investigate. But anyway, so let's just make a quick patch just to check out what kind of cool stuff we can do here. So we're using X1, X2, X3, X4. We've got them routed out here. So now let's do something like invert. So we can now write these Y counters, which, so if I'm just going to route one of these just to something so we can see what it looks like. So you see as I turn this off and on, you can see these horizontal. I mean, that's kind of a bad example. I'll show you what these things look like kind of by themselves. Right. So yeah, let's do this kind of in order. So X counters starting from the lowest and going up, we get thinner and thinner lines in the X direction. Until we get to very, very thin. And this video on the top right is being scaled a bit, so we might see some distortion. And the same thing applies to Y, Y across. So we've got, thinner and thinner Y lines. And our outputs here, we address individual bits for the output in the EMS. So, for example, let's say I do this, which is what I was doing before. Now we have a gradient because we're applying tighter and tighter vertical lines to luminance. And so we get a gradient. It's not very intuitive to think about it. And we have plans for interface stuff that will make it much more performative and intuitive. But this is like a classic kind of mode, because I feel like there's something real sort of value in interacting with it the way that, you know, God intended. So let's see, we've got these, so these X counters are routed to our limiter outputs. Now let's try something like inversion. So now I'm using these Y counters to invert. Let's do this. To invert these X counters. Very fun. So now you can see we're already starting to get some pretty nice sort of patterns here. Let's do something else. So we're taking X0 here. I'm going to turn it off. Let's send it to an overlay gate. So I'm going to send it as there. Overlay gate will reappear over here. And so now it looks like we got a signal back. But our overlay gate is actually gives us an XOR connection to something else. So now we can run in another signal to kind of further modulate what is coming out of the way that X0 appears. Let's see. Cool, now we got this nice, you know, you can see as we go through we start to get different kinds of patterns. I quite like this cross. Yeah, that's quite fun. So what else have we got in here? So along the left side, these are all the outputs. Along the top, these are all the inputs to the matrix. Think of the top like as our source. This is where like things come from, and on here, this is where things go to. It's flipped from the original EMS. We're going to flip it. It's just backwards for now. We've got all our counters. So these are the vertical and horizontal lines we were looking at before. We've also got slow counters. So these are increasingly slow triggers that we can use for stuff. So this is a way that we can get like movement and shifting animations. And it goes right down to 0.2 hertz. We can actually go much slower using flip-flops. But what else have we got? So we've got slow counters, we've got overlays. So like I was saying, they're an XOR gate essentially with two inputs that we can route to them. Invert, that's exactly what you'd expect. We can run a signal in and then invert it with no other control. We've got edge detection. So there are there's one edge detector that comes in here. So let's route, and the edges go in the X direction. So we need something like X6. And now let's look at our outputs from the edge detector. Shoo. I'm going to scale up this video output so we can see a bit better what's happening. And I cover my face. Down in the corner. Great. So now you can see we're getting kind of sharper edges. So let's leave that on. And let's change what runs into the edge detector. So now you can see these little, come here, come off. Now you can see these little green lines appearing. So that is the leading edge that we're detecting there. We can also detect the falling edge. So leading edge, falling edge. And we also have a thicker version. So we also have thicker versions of these edge detects that look nice as well. Delays, flip-flops. Look, there's lots of stuff here. I think maybe the best thing to do is just to build a quick little patch and see kind of what fun stuff we can come up with. Let's run my edge detect to invert count Y7. Let's take the wide one. and 1. Now we've got some fun stuff going on there. I'm going to set up a swap. Okay, so for some bizarre reason, when I moved over to this full screen, we lost audio from my mic. But that's okay, because I don't think I was saying anything that was particularly important or interesting. I was mostly just talking about what I was doing kind of absent-mindedly. Talking about how I was connecting various things together. So, I mean, honestly, you're not really feeling like much. You don't really feel like you're missing very much. I'm kind of going through testing different parts. That rolling you can see is from the delay. So there's should be 800, I think it's microsecond delay. That's not, it's not perfect. A lot of stuff's not perfect. What we're looking at now is Luma feedback. So the Luma output is by default routed back around into the comparator inputs. So it's acting like an external video source. At the moment, the delay is so short that it's not really giving the kind of feedback that I want. Is more of a, proof of concept, so that hopefully in the future I can have a much, kind of larger delay. Maybe it'll even, exit the FPGA to give it even more of a delay. So you can see, keep in mind this is still only one pin per output. So this is just a small fraction of what you can do with just the digital side. Once you have a matrix like this, you really, have the ability to quite easily introduce new things like I built some cellular automata stuff that some 2D cellular automata stuff that can just feed quite easily into this, and you can start to introduce things like sequences and other kinds of great little things. So this was meant to be quick, but I don't think it has been. So thanks for tuning in, and hopefully there'll be more updates soon. See ya.